Hey, on this video, we're going to go over question 13 from your study guide. In this one, we've got Bob dropping a 5-kilogram ball off the edge of a building, and it goes into the mud below. We're going to find the maximum velocity of the ball, the impact force on the ball from the mud, and draw some free body diagrams. So we here have our diagram of Bob. He's dropping the ball. Its initial velocity is 0 meters per second because he's just dropping it from rest. The height that it falls before it hits the mud is 8 meters, and then it sinks 0.7 meters into the ground. So for part A, we're finding the maximum velocity the ball reaches, which happens just before it hits the mud. So this goes back to our previous unit on motion, and this is just a vertical motion problem. So for this, we're going to look back at those formulas, and we're going to find the one that works is the our final velocity squared equals our initial velocity squared plus 2 times our acceleration times our distance, because we don't know the time that the ball's falling for, so none of the other formulas from that unit are going to work because they involve time. Ultimately, we want to find this final velocity because that's the maximum velocity it hits, right? It's the fastest right before it starts hitting that mud. Its initial velocity is 0 squared, so that's going to go away, plus 2 times its acceleration. Now, normally we were using negative 9.8 for this. That negative's job was just telling us which way we're going, and we know we're going down in this problem. So we're just going to focus on a positive 9.8, and then the distance here is 8. Now, if you wanted to really put negative 9.8, you would just need to also match it with a negative 8, and then the negatives will cancel out because the 8 meters is dropping in that negative direction. So back to this, 2 times 9.8 times 8 is, we're going to multiply that. We're going to get 156.8 when we do that, and that equals VF squared. Now, we don't want to stop there. We want just VF because that's the final velocity, or in this case, the max velocity the ball reaches. So we're going to square root that, and we're going to get a final velocity of 12.52 meters per second. And that's the maximum velocity, the maximum speed this ball is going to reach, because right after it hits that, it starts hitting the mud, and the mud is slowing it down. So that is our answer for A. All right. Now for B, we want to find the impact force on the ball. And the easiest way to go about this is just using the formula that I taught you guys, which is your impact force equals your mass times your acceleration due to gravity times the height the ball falls before it starts hitting the mud, divided by the distance that it's sinking into the mud. So we have the mass of the ball was 5 kilograms times our acceleration due to gravity is 9.8 meters per second squared times the height that it falls was 8 meters, and then it sinks 0.7 meters into the ground. So then we're going to work that all out in the calculator. Very easy to do. And you are going to get an answer of 560 newtons when you do that. So that is the impact force that this mud is pushing up on the rock to stop it from sinking in even further. All right, moving on. We've got our 2 free body diagrams to work out now. So let me clear some room. For the first one, we are finding it when it's falling in the air still, and then the second one, we are finding it when it's hitting the mud. So for the first one, we're just falling through the air. So think about what forces are going to be acting on it when it's falling through the air, and I hope you're thinking force of gravity because you would be correct. So we'd want the force of gravity of it. We hadn't found that already, so it's just going to be your mass times acceleration due to gravity. So our mass of our ball was 5 kilograms times 9.8 meters per second squared. And that is going to equal a force of gravity of 49 newtons. And that is actually the only force acting on the ball, at the rock at this point, or the ball. Because in this case, I didn't say this, but for these problems, we're ignoring air resistance. So the only force acting on it as this falls to the ground is going to be your force of gravity. We're ignoring the air resistance that could be opposing this. So that is for C. Then for D, we are now constructing a free body diagram for when it's in the mud just before it's stopping. So we have that impact force of the mud acting against the rock to slow it down. So you still have your force of gravity, of course, and that's still 49 newtons. That's not going to change just because it's in some mud. But now we have that force of the mud, and you can label this as an impact force. You can label it as technically it's applied force, the mud pushing up. You can put just force of the mud on there if you'd like. I'm not too picky about that. But that's going to push up, and that's going to be that 560 newtons that we found earlier. That's going to push up against it. So that's going to be for D here. All right. So that's it for question 13.